So we're going to look at our solving systems. We looked at graphing last week. This week we're going to look at the other two methods. The first one for the next 2 days will be substitution. So substitution's all about plugging in one equation into another. Just like in sports, one player comes out, another player comes in. Things that we're looking for. We're looking for a y equals equation or an x equals equation. Not equals 0, sorry. X equals. That means if we don't have one, we have to create one. That's what we're going to look at on the last few problems today and the major focus for tomorrow. So looking at my two problems here, the first thing that I'm going to look for is my first equation an x equals or y equals? Is x or y by itself? The answer is no, so we're going to move on to the next one. Our second equation does have a y equals. Substitution is a go. For substitution, the organization is the best when the two equations are side by side rather than vertically aligned like this. So now that I have them side by side and I have a y equals, and y is equal to all of this, I'm going to take all of that and plug it in for the y right here. The entire equation, except for the y, remains the exact same as it was. So look, it's a minus, 3, x. The whole thing. The only thing that's missing is I've taken this y out, and I am substituting in the expression I have circled over here. The equation that we have here only has one type of variable. Because it only has one type of variable, we're able to solve it. I'm going to distribute the -2, so that gives us -3x minus 2x plus 6 is equal to -19. Combine my like terms right here, so that gives us -5x plus 6 equals -19. I subtract 6 from both sides. -5x equals -25. Divide both of the sides by -5, so all of that, so x can get by itself and become 5. That's actually only half of our answer. So we're going to use that answer right here, and we're actually going to do another substitution. Since x is 5, we're going to be able to plug it in for this x. We get 5 minus 3, and y equals 2. And now we have our final answer. So with substitution, there will always be two substitutions happening. We plug in the expression, solve for a number, plug it back into the other equation, and get our answer. Let's try that again. Once again, I have a y equals, so we are able to use substitution. So y equals 4x minus 5, and then we have 6x plus 3y equals 3. I'm going to take this whole thing right here, plug it in for y. So we have 6x plus 3. This is where I would have written y originally. And we're going to substitute the y out, and we're going to plug in my circled expression. You always have to put it in parentheses. We're going to distribute that 3. It gives us 12x minus 15 equals 3. Combine my like terms and I get 18x minus 15 equals 3. I add 15 to both sides. I get 18x equals 18. There we go. Divide by 18 on both sides, and x equals 1. Once again, that is only one of our answers. So I'm going to take that x equals 1, substitute it back in right here. Y equals 4 times 1 minus 5. That gives us 4 minus 5. 4 minus 5 is negative 1. And there we have it. Say we have an equation where it doesn't already say x equals or y equals. We have x plus 4y equals 12. And we have 7x minus 4y equals 20. Neither of them say x or y equals. So what we're going to look for is we're going to look for any of these terms that don't have a number accompanying it. So we're going to look for no coefficient. Coefficients are the numbers that are in front of our variables. Because all three of these have coefficients, it's actually the best to get this x by itself. To do so, we subtract 4y, and in one clean step, we have an x equals. This is where mistakes happen the most. Since it's an x equals, that's going to go in place of x. So we have 7, parentheses, negative 4y plus 12, end parentheses, minus 4y equals 20. Distribute that 7, we get negative 28y plus 84 minus 4y equals 20. Combine our like terms, and we get negative 32y plus 84 equals 20. Subtract 84 from both sides. You get negative 32y equals negative 64. Divided by negative 32. And y is simply 2. That is a decent amount of work, but we're not quite done. We have to take that and substitute it back into our other column here. So we replace the y with a 2. Negative 4 times 2 is negative 8. Negative 8 plus 12 gives us 4. For our final problem in this review window, I once again have no x or y by itself. And this problem, we actually have 3 good choices to get by themselves. This x is almost by itself, this x is almost by itself, and this y is almost by itself. This 4 would be a poor choice. We should not choose to get that one by itself. I'm going to avoid the negative, so I'm really choosing between x and y over here. Both of them are just as simple. In this case, I'm going to get x by itself. With the negative y and the negative 1, we get this expression. I can now plug all of this in for the x over here. For our side note here, it does not matter which variable you choose to get by itself. Certain variables will create harder problems than others, but if you do the math correctly, which I know is kind of the catch-all in all of this, you will get the same answer regardless of which path you take. Just some will be easier than others. So I'm going to plug that in for the x. It only goes in for the letter x. So that minus sign on the outside does not go away. It is just the x that is affected. I then distribute this negative and gives me y plus 1 plus 4y equals negative 4. Combining like terms gives me 5y plus 1 equals negative 4. I subtract 1 from both sides. 5y equals negative 5. Divide both sides by 5. And y is negative 1. Again, half of the answer. We take that number, We plug it in back up here. We get x equals negative 1 minus 1. Again, this minus does not count for this minus. We're only taking out the y. So we have 1 minus 1. And the answer is 0. Record that as a coordinate point, and we're done.